PIN photodiode. PIN photodiode. The outlines will discuss basics of PIN photodiode, construction of PIN photodiode, working of PIN photodiode, and advantages, disadvantages of PIN photodiode. As name indicates, this diode has intrinsic layer sandwiched in between two highly doped P-type and N-type layers. It gives performance improvement compared to PN photodiode. PIN photodiode has layers as per P plus, I, N plus. P plus indicates heavily doped. P plus and N plus layers has less resistivity, around less than 1 ohm. An I layer has high resistivity, ranges from 10 ohms per centimeter to 100 kilo ohms per centimeter. PIN diode has larger depletion area. This is the structure of PIN photodiode. So under zero bias condition, we are not applying any voltage. So P plus is made up of indium aluminum arsenide, and I layer indium gallium arsenide. N plus layer we have indium phosphate. So I layer and N plus, then the region is the depletion region. So when light falls on the depletion I layer, the depletion layer increases. As we know, C is equal to epsilon naught into epsilon R into A by D. As the distance is more, capacitance gets reduced. Okay. So P type this is under reverse P is connected to negative P plus, and N plus is connected to positive of the battery. So this is under reverse bias condition. So what happens as it is connected same as PIN diode, the charge carriers, minority charge carriers will be increased, and the depletion layer starts increasing. So as the depletion layer increases, current is increased due to the photons, and then so current will be more, depletion is very large because of the minority carriers that are generated by in P plus and N plus. And if we connect to positive forward bias, then what happens under the forward bias condition, current will be minimum, negligible. What are the advantages? It has very low reverse bias necessary, high quantum efficiency, it has got large bandwidth can be obtained, and it has low noise performance. Disadvantages, it doesn't amplify the signal. So this is the structure as it will. Thank you. Next, avalanche diode. This avalanche photodiode. Basics of avalanche photodiode. We'll discuss the operating principle of avalanche photodiode, structure of avalanche photodiode, working of avalanche photodiode, electric field profile of avalanche photodiode, and advantages, disadvantages. Now, basics of avalanche photodiode. In case of conventional photodiodes and PIN photodiodes, output current is very small, that is under 100 microamps. So this is because these photodiodes gain is less than 1. To obtain high current, high gain, we use avalanche photodiode. Operating principle of avalanche photodiode. Here reverse bias applied near to breakdown voltage. Instant light will produce electron hole pairs. These carriers will travel with a saturation velocity. As velocity is maximum, these carriers will collide with other atoms. So new electron hole pairs are generated. This way, that is called the avalanche. These new carriers also travels along with the initial carrier. Therefore, this increase in carrier will increase current. This process of generating more number of carriers is called as impact ionization. The structure of avalanche photodiode is made up of silicon, which gives 90% efficiency, and APD avalanche photodiode has layers as per P plus, pi, P, N plus. Here P layer is having high resistivity, so all the reverse bias is mostly applied across P N plus region. Because P has got a more high resistivity. If reverse bias is increased, then the depletion region also increases. See the electric field, how it would be in the depletion region. So when P plus N plus we have connected, P N plus we have connected. This is under reverse bias condition. The pi region is very large. The charge carriers when P positive, P plus moves to P. So what happens? P and from P N plus P forms the junction. So these carriers from heavily to P holes or P plus enters the pi region, and more carriers will be developed in pi region. So these charge carriers which are residing in pi region will collide with the holes of P region next to pi region. Then the junction will be this junction will be increased. Here the depletion layer forms, and what happens from P to N plus the charge carriers move. So the majority carriers in P type holes and N plus electrons. So N plus connected to plus and P plus is connected. This is under reverse bias condition. As the P region increases, the current under reverse bias condition due to the light increases. So what happens? The electric field in N plus starts increasing. At the junction it will be maximum, and when it reaches to P, the electric field will be minimum, and from P to pi region is absolute minimum, and it maintains the uniformity, and in P plus region the electric field increases slightly. Working of avalanche photodiode. Due to light, electron hole pair is generated from P plus more from pi layer. Due to very high reverse bias voltage, these carriers move with very high velocity towards P N plus region. At P N plus region, impact ionization takes place. Due to very high reverse bias voltage, these carriers move with very high velocity towards P N plus region. At P N plus region, impact ionization takes place. That means more charge carriers is there in highly resistive region. That's P region. Electric field, the electric field required to do impact ionization is from 10 to the power of 4 to 10 to the power of 5 volts per meter, and this will increase the photocurrent. About 200 gain could be obtained in this diode. Here the most important factor is that the material should not have defects, and it should detect if such defects are present, then the total photocurrent will be reduced. Advantages: it has got more avalanche gain, and disadvantage: highly operating voltage is required. At high voltage noise is very high. Avalanche means output is not linear. Thank you.